In this video, we'll take a brief look at guidelines for selecting primary keys. How important are primary keys? Arguably, the most important characteristic of an entity is its primary key. That is, a single attribute or some combination of attributes which uniquely identifies each entity instance. For example, in the product table, the prod code is the primary key that uniquely identifies each distinct product. The primary key's function is to guarantee entity integrity. That is, in the product table shown, there cannot be two different products with the same product code. Each product has its own unique prod code value. Furthermore, the primary keys and foreign keys work together to implement relationships in the relational model. For example, the prod code column appears as a foreign key in the invoice line table and allows us to identify each product ordered. A natural key, or natural identifier, is a real-world, generally accepted identifier used to distinguish real-world objects. As its name implies, a natural key is familiar to end users and forms part of their day-to-day business vocabulary. The concept of a unique identifier is commonly encountered in the real world. For example, you use class or section numbers to register for classes, invoice numbers to identify specific invoices, and account numbers to identify credit cards. So what are some of the basic guidelines for primary keys? Unique values. It is important for a primary key to have unique values in order to uniquely identify each entity instance. It cannot contain nulls. Non-intelligent. A primary key should also be non-intelligent. This means that it should have no embedded semantic meaning other than to uniquely identify each entity instance. Remember, the purpose of a primary key is not to describe an entity. For example, imagine a business that uses a combination of the last name and date of birth as a primary key for customers. What would happen if the person gets married and she decides to change her name? This is the reason why primary keys should not have any semantic meaning. Unchanging. The primary key should not be susceptible to change over time. As we saw in the previous example, using a primary key that is subject to change over time is not ideal. If a primary key is subject to change, the foreign key values must be updated, thus adding to the database workload. A single attribute. It is preferable to make primary keys contain only a single attribute. This simplifies the implementation of foreign keys and reduces database workload. However, as you'll see later, composite or multi-attribute primary keys are also common in database implementations, but single-attribute primary keys are preferred. Numeric. Though not required, primary keys should preferably be numeric because unique values can be better managed when they are numeric. For example, dates are not necessarily good candidates for primary keys. Among other obvious reasons, dates are managed differently by different database management systems. Security compliant. This means that the selected primary key must not be composed of any attribute or attributes that might be considered a security risk or violation. For example, it is not wise to use a social security number as a primary key in an employee table. So the next question is, when to use composite primary keys? While it is preferable for a primary key to use only one attribute, that does not mean that composite primary keys are not permitted in a model. Composite primary keys are particularly useful in two cases: as identifiers of composite entities, in which each primary key combination is allowed only once in the many-to-many relationship, and as identifiers of weak entities, in which the weak entity has a strong identifying relationship with the parent entity. Let's take a look at these two cases further. Let's discuss the use of composite primary keys in composite entities. In some composite entities, each primary key combination is allowed only once in the many-to-many relationship. For example, let's assume a student entity set and a class entity set. In addition, assume that those two sets are related in a many-to-many relationship via an enroll entity set, in which each student-class combination may appear only once in the composite entity, to represent the fact that a student can only enroll once in a class in a given semester. As shown in this figure, the composite primary key for such a relationship automatically provides the benefit of ensuring that there cannot be duplicate values. That is, it ensures that the same student cannot enroll more than once in the same class. In other words, each class code and student number can only occur once in this entity set. In this scenario, composite keys are a valuable construct to implement a many-to-many relationship. Now let's see the use of composite primary keys on weak entities. Imagine the real-world object invoice. This object is represented in the data model as two entities, invoice and line, that share a strong identifying relationship. Two entities are in a strong identifying relationship when the primary key of the dependent entity, line, inherits the primary key of the parent entity, invoice, as a primary key component. Notice that the line composite primary key inherits the invoice number primary key component from the invoice table. The strong identifying relationship highlights the fact that the invoice and line entities are really one real-world object. Clearly, the line entity does not exist in the real world as an independent object, but as part of an invoice. This is another valid use for composite primary keys. This concludes this presentation.